大家好，我是李明辉，学号是194105317, and this is my numerical method final project, and the topic that I chose was the heat transfer in air conditioning room. Before we start, we're gonna run the code in the background as well as I'm explaining the code to you guys. Right here. Okay. We start writing our code by writing our parameters, which is A, which is the thermal diffusivity of air in 40 degrees Celsius, which is 2346, and the length of the room, which is 5 times 5 times 5 meter, and the time of the simulation time is 60 seconds, and the nodes of the nodes in each direction is 50. And here is the time step. We need the time step to be small enough to ensure numerical stability. And here we set up our nodes, which is initially a 40 degrees Celsius, and the boundary conditions of the room is 20 degrees Celsius in all phases of the room. Here is the visualization setup to create a figure for the 3D plot, and here is the code to run the simulation until the simulation time has been reached. And we make a W, which is the copy of the current temperature, and here is the code of to update the temperature of the internal nodes. And here is the second derivative of the temperature, which represents the heat flow in XYZ direction. Right here. This is original from the finite difference method. We just write the equation right here, but this is originally a 2-dimensional one, and I updated it into a 3-dimensional one. And here we're gonna update the temperature at node ijk based on the heat equation and add the dt into the time counter. And finally it prints out the current simulation time and average temperature. And finally here is to create a mesh grid for the plotting. As you can see, this is the final simulation, and the temperature has cooled down into a 30 degrees Celsius in 60 seconds. I know this is a bit impossible for a 5 by 5 by 5 room to cool down this fast, but this is so that we can simply see how the room can cool down. Here is my final project. Thank you very much.